Hello maths fans! Dr. Tom Crawford here at the University of Oxford with a very special treat for you, as today we are going to be exploring the Pokemon catch rate formula. This is the mathematical algorithm used in the original Pokemon Red and Blue video games to determine whether or not you are successful when trying to catch a wild Pokemon. And here it is, the formula for the probability of catching a wild Pokemon in the Generation 1 video games. The probability of catching a Pokemon P is equal to S plus 1 divided by B plus 1 plus the minimum of C plus 1 and B minus S, all divided by 256 times B plus 1. That's multiplied by 1 plus the minimum of 255 and the floor of HP max times 255 divided by B mod, all divided by the maximum of 1 and the floor of HP divided by 4. Complicated is an understatement. Okay, so what does it all mean? Let's start by defining the numerous variables that are appearing in our formula. So first we have S, which is the status. So S is equal to the status of our Pokemon, and it can take a few different values. It has a value of 0 if there is no status effect, so no status. Has a value of 25 if the Pokemon is asleep or frozen, and it has a value of 12 if the Pokemon is burned or paralyzed or poisoned. So all possible status conditions will have some effect on our catch probability. Next, we have the variable B. This is the ball type. So this varies depending on the ball being used to try to catch your Pokemon. So this can have 3 values. It has a value of 255 if you're using a Pokeball, has a value of 200 if you're using a Great Ball, and it has a value of 150 if you're using an Ultra Ball. Next we have C. This is the catch rate of our Pokemon. This is an integer value which can range from the rarest Pokemon, the legendaries, that have a catch rate of 3. So any of the legendary birds, Articuno, Zapdos or Moltres or Mewtwo all have catch rates of 3. And something like a Pidgey has the maximum catch rate of 255. Next we have HP max and HP. So HP max is going to be the full health, full HP of the Pokemon you're trying to catch, and HP is going to be its current HP. And then the final one is going to be B mod, which is in here. Now this can take 2 values, and it's either equal to 8 if you're using a Great Ball, or it's equal to 12 if you're using a Pokeball or an Ultra Ball. And that should cover everything in the formula. Doesn't necessarily make it easier to understand, but at least now we know what all of these variables mean. So next we can try and understand the maths and what's going on with all of these symbols. Okay, so how do all of these variables interact according to our formula? Well, let's have a look. This first piece is quite straightforward. This is simply a constant value, which is the status condition plus 1, divided by the ball type value plus 1. This we can understand, it's just a fraction. Now the next part has 2 key components. First piece here, second piece in this curly bracket. So what we need to do is take our catch rate for our particular Pokemon and add 1, and then take our ball type value and subtract the status condition. And then we take the minimum of those two values. So this will give us two numbers. We take the minimum of those two numbers. Then we divide by 256 multiplied by b plus 1. Again, we know the value of b dependent on our ball type, so this will just give us a rather large number, but we're going to have a number on top divided by a number on the bottom. Then that whole thing is multiplied by 1 plus this minimum. So we need to calculate this thing inside the floor function and compare it to 255 and then take the smaller of those two values. So we take the HP max, full HP of our Pokemon, multiply by 255 and then divide by the ball modifier, which is either 8 or 12. That gives us a number. We then take the floor function of that number. So what that means is calculate the fraction on the top, get an answer. Let's suppose it's 70.3. Floor function says take the integer part of that. So round down, always down to the nearest integer. So if we had 70.3, it would be 70. We do the same on the bottom. We calculate current HP, the life that we have reduced the Pokemon to. Divide that by 4, and again take the floor function to make sure we get an integer value, because clearly this is all the game could process. And then we take the maximum of 1 and that. So that is just making sure that we can't get a 0 value and divide by 0 and mess everything up. So that's all that maximum is really doing. So we have the number on top, suppose it was 70, number on the bottom, suppose it's 10. We divide them and we would get 7, and then we take the floor function. So if I did get 7, I don't need to round down, I'm already at an integer. But if I had another number, say 6.3, I'm going to be rounding down because of this big floor function. And then I'm taking the minimum of 255 and this whole thing. So there's clearly a lot of computation going on over here, and we have these various appearances of maximums and minimums and floor functions, but ultimately they're all just there to make sure we get integer values, because clearly that's all that Game Boys could process in the 1990s. So given that all of these complicated functions, maximum, minimum, floor functions, given they're only really included because these are quite old games, let's make some simplifications. And what we're going to do, and what we're going to work with when investigating the formula, is going to be the approximate probability. So I'm going to call this p hat. So p hat is going to be equal to s plus 1 over b plus 1. So as I mentioned before, that's reasonably straightforward. We just compute that. Then we want the minimum of these two values. Now, the smallest value we can take for b is going to be 150. And the maximum of s is 25. So the smallest this can be is 125. But if we're trying to catch a rare Pokemon, like a legendary, or my non-legendary favourite, Butterfree, which has a catch rate of 45, C plus 1 is generally going to be less than this for most of the Pokemon we care about, the ones that are hard to catch. So in the majority of cases we want to investigate, the minimum of these two will be C plus 1. So let's just suppose it is. And of course that's why this is an approximate probability. So let's just suppose that's C plus 1. And then what we're doing is dividing by 256 times b plus 1. 256 is of course just a number, and b plus 1 is again from our ball type, so that's okay. Now the complicated part, I'm going to start by just saying this is then multiplied by times square bracket 1 plus f, and what I'm going to do is define f to be this thing, but without the floor function. So we're going to say where f is going to be equal to, we're going to assume that this in general will be smaller than 255, so then we can remove the minimum, and we want HP max times 255 on the top So HP max times 255. And then we're dividing by B mod and also dividing by, let's take the maximum to be HP over 4. So HP over 4, so that's going to put 4 on the top. So that's that times 4 divided by B mod times HP times B mod. So we could substitute for F into this bracket, and that gives us our approximate but much simpler formula for the probability of catching a wild Pokemon. So now that we have our simplified approximate formula for the probability, the best way to try to understand this is going to be through an example. So let's make some sensible assumptions. My Pokemon is going to be asleep. I certainly always use sleep powder when trying to catch a Pokemon. So S is going to be 25, and we're probably going to be using an Ultra Ball. So that means that B is therefore going to be 150. And we're going to treat the other two remaining variables as F, and to keep F, of course it has several variables inside it, but I'm going to keep it as its own variable, as is, and C, the catch rate of the Pokemon, is going to be our other variable. So what I can actually do, given I have two variables, is create a 3D plot, create a surface plot of this probability function in the case of my Pokemon being asleep and the fact that I'm using an Ultra Ball. So what I would have as my function is going to be Z equals. Z here, remember, represents the probability. So I have a constant at the beginning, so 25 plus 1, so that's going to be 26 divided by 151, so that's a little bit over 1/6. And then add, now let's relabel C as X. So the X-axis represents the catch rate of the Pokemon. So plus X plus 1. And then we have 1 plus F. So F here is going to be Y. So the Y-axis represents the HP factor, or the health factor, because clearly this depends a lot on the Pokemon's health. And then we divide by 256 times 151, which I worked out earlier on my calculator to be 38,656. So we divide by 38,656. So this gives me now a function in two variables, X and Y, where X is representing the catch rate of the Pokemon, Y is representing the HP factor of the Pokemon, and Z, the surface, gives me the probability. Using the Maple Calculator app on my phone, I can take a photograph of our surface equation, like so, and this will automatically insert this equation into the app. And then if I click on 3D plot, I can actually see a plot of the surface, where remember the height Z represents the probability of catching the Pokemon. Our variable X is the catch rate, labeled as C up here, and the variable Y is the HP factor, which is this equation here. We can see that the surface is very steep with sharp edges, but if we remember that our variables here, X and Y, represent positive values, we can focus in on that particular area of the graph, and we can see a very steep increase in the height as both X and Y increase. So what this means overall is that a Pokemon will be easier to catch if it has a higher catch rate. Probably could have guessed that one. And also if the HP factor is as large as possible. So in order to make F large, we can do this in several ways. We can make the HP max value of the Pokemon larger, so possibly trying to catch Pokemon of a higher level could help out here. And also we want the current HP of the Pokemon, this variable on the denominator, to be as small as possible. So reducing the Pokemon's health will overall lead to an increase in F, which therefore on our surface leads to an increase in Z, which represents the catch probability. So we want Pokemon with high catch rates and low health will ultimately help us to improve our chances of success. The Maple Calculator app is completely free, so I do recommend downloading it for yourselves and having a play around with our formula to see what else you can discover. So now we have a better feel for the formula and how it works. You are no doubt wondering, where on earth does this mess come from? And this comes down to the algorithm. Now, there are two key steps in the algorithm, which I'm going to call route 1 and route 2. So route 1 works as follows. We begin by generating a random number n. So n is a random number and it belongs to 0, 1, 2, ... And this continues to a maximum value of 255. Now, this can be reduced by using a different ball. So this will actually go up to B. So it generates a random number, which could be from 0 to 150 if you're using an Ultra Ball. It could be 0 to 200 if you're using a Great Ball, and it could be 0 to 255 if you're using a Pokeball. So the generation of this number comes from a smaller set when using a better ball. Once we have our randomly generated number n, and we assume that they are uniformly distributed, so it's equally likely for n to be any of these b+1 possible values. Once we have the value of n, that is then compared to the value of S, the status condition. So we say that if n is less than or equal to S, then the Pokemon is caught. So Pokemon is caught. So what this means is if you put your Pokemon to sleep and immediately throw an Ultra Ball, there is some non-zero chance you may catch that particular Pokemon. And this, in fact, this non-zero chance is exactly this contribution here in our probability formula. Because there are b+1 total possible values that n could have. Out of those b+1 values, exactly S+1 of them would mean the Pokemon was caught. Because we could be 0, 1, 2, 3, all the way up to the value of S. So because of the 0, that's why we add the 1. So randomly select an n. If it happens to be quite small, smaller than whatever status condition your Pokemon has, you immediately catch the Pokemon. There is a non-zero probability associated with this, and that is going to be route 1, the first component of our catch probability formula. For larger values of n, we do still have a chance of catching the Pokemon, and this is where route 2 comes into the algorithm. So this is going to be the second part of our probability formula. So for route 2, or step 2 in the algorithm, n is now compared to the value of S plus C. So we say if n is smaller than S plus C, then the Pokemon isn't caught. That'd be too simple. Then what we do is we generate another random number, then generate a number, let's call it m, and m goes from the full range 0, 1, 2, ... up to 255. So this one is not restricted by the choice of ball that's being used. Now this second randomly generated number m, with an equal probability 1 over 256 of being any of these 256 choices, this is then compared to our HP factor f. So option 1 is to say if m is less than or equal to f, then again, success, the Pokemon is caught. But if not, so if m is bigger than f, then Pokemon escapes. And it is perhaps worth just stating, hopefully you realise, but I'll write it anyway, that if n is bigger, so if n is bigger than s plus c, that also means the Pokemon escapes. So, to reiterate, route 1, generate a random number n. This is a number from 0 up to b, where b is your ball type. Each one of those is equally likely to occur. If this number is smaller than your status, values given here, then the Pokemon is caught. Hooray! Part 1 of our probability. If n is larger, but still smaller than s, the status, plus c, the catch rate, over here, which varies depending on how rare the Pokemon is, if it's larger than route 1, but still smaller than s plus c, then we generate a second random number, m. We then compare this number m with our HP factor f. If m is smaller than f, the Pokemon is caught. That is going to be route 2. However, if m is bigger than f, then the Pokemon escapes. And just to round everything off, if n is really big, the number right at the beginning is far too big, bigger than s plus c, then the Pokemon will also escape. As we saw with the first part of our probability coming from route 1 of capture, the second part here actually comes from this second route of capture. And we're only interested in, remember, the one here where it's actually caught, because the others won't contribute to our probability. So what we're saying here is that there, beyond the initial s plus 1 values for catching the Pokemon, there are actually another c plus 1 possible values, that's where the c plus 1 comes from, out of b plus 1. So again, there were b plus 1 values of n. The first s plus 1 of them mean success. The next c plus 1 of them mean we move into route 2. So you could, in theory, say this part here is the probability of entering route 2. But of course, route 2 by itself doesn't guarantee success. So this is the probability of entering route 2. And then for route 2 to be successful, we pick our second random number m. There are 256 numbers, so this is picking m. 256 choices, equally likely. And of those choices, as long as we are smaller than f, then we are successful. So there are f plus 1 possible choices here for the Pokemon to be caught, which is this final factor here, which is down to this. So the original formula, as I've said several times, is very complicated and rather messy. But when you break down the algorithm, you can explicitly see where each piece of the algorithm relates to the probability of catching the Pokemon and how we then add up all of those pieces to get our final formula. So what does this all mean? Well, for starters, status conditions are very much your friend. So having a Pokemon that is asleep or frozen gives you an immediate boost to bump up that catch probability. And that is true regardless of the Pokemon you're trying to catch, or the ball you're using, or the HP or anything else. Statuses are great, really good way to improve your probability of catching a Pokemon. Second, lowering the HP of the Pokemon you're trying to catch is a great idea. If you lower the HP, the number on the bottom here goes down, which means F goes up. And we've already seen from our plot in the Maple Calculator app that we want F as big as possible to boost that probability. So lowering health is good and status conditions are good. It would also be nice for the catch rate C to go up to be as large as possible. However, we can't control that as a trainer. C is fixed depending on how rare the Pokemon is, so unfortunately we just have to deal with the fact that it will be harder to catch a legendary Pokemon. Who knew? Which just leaves our choice of ball. Now looking at the first component, root 1, part 1 of our probability, we want B here to actually be as small as possible. So the B here being in the denominator means we want a small b. We also have a b in part 2 in the denominator, so again we want b to be small. So these two occurrences of b suggest the Ultra Ball is going to help us. As we are told in the game, Ultra Balls lead to an increased chance of catching a Pokemon, apparently. However, and this is why I said apparently, B mod. This is on the denominator of F, and we want F big. The HP factor has to be big to increase our overall probability. So we want B mod to be small, and B mod is 8 for a Great Ball and is 12 for a Pokeball or an Ultra Ball. So if we use the Ultra Ball, we have a smaller value of B in these two denominators, but B mod goes up. So it's not quite as straightforward as saying an Ultra Ball will help. Low HP, status conditions, frozen and asleep, all massively boost our chances. But it's not quite so simple when it comes to the choice of the ball that we're using. So as a final exercise, I'm going to have a quick look at comparing the use of an Ultra Ball with that of a Great Ball to see when one might be better than the other. To compare the Great Ball and the Ultra Ball, we are going to first introduce a new variable h, where h is going to be equal to the current HP divided by HP max. So h is going to be the proportion of HP remaining. With this new variable, and using the values for B and B mod that we have over on that side of the board, we can now write down the probability catch formulas for the Great Ball and the Ultra Ball. So let's call it PG for the Great Ball is equal to S plus 1, that hasn't changed. The value of B is 200, so we divide by 201. Then we have plus C plus 1, that also hasn't changed, divided by 256 times B plus 1. So that's 256 times, what's it going to be, 201, which I calculated earlier, to be 51456. 51456. Just 256 times 201. Multiplied by 1 plus f, but f is this. So multiplied by 1 plus, now we have this new variable, which is going to be a h on the denominator. So we're going to have plus 255 times 4, I can do that one in my head, 1020 divided by h times b mod. B mod for the Great Ball is 8. So divided by 8 times h. So this is our probability when using a great ball. And for an ultra ball, very similar, call this P of U. It's going to be equal to S plus 1 over 151 plus C plus 1 over 256 times 151. That's 38656. And that's multiplied by 1 plus, again, 255 times 4, so that's 1020, divided by now 12 times h. So the only two differences, number here, 8 versus 12, and then we have a larger number on the denominator in both of these first two for the great ball compared to the ultra ball. Comparing the two formulae, we can see that for part 1, or route 1 of catching the Pokemon, it's undoubtedly going to have a higher chance of success when using the Ultra Ball. This number for a fixed S, this number is bigger than the one for the Great Ball. However, for route 2, or part 2 of the algorithm, we're actually seeing conflicting behavior because we have a larger denominator for the Great Ball outside the bracket, but a smaller one inside, and you have a smaller number outside for the Ultra Ball, but a bigger one inside. So as H varies, as the proportion of the HP remaining changes, which of course it will when trying to catch a wild Pokemon, you could see a switch between which one is better to use. It's very hard to see that by looking at the formulas as they're written, especially because the numbers aren't particularly nice. So what we're going to do is look at some graphs. So I've actually put together a worksheet in Maple Learn, which you can all access yourselves by clicking on the link in the video description. It's completely free, and it's also completely editable, so you can actually change the values of all of these parameters and see for yourselves how it impacts our probability of catching a Pokemon. The variables S and C can be set to any of the allowed values, which are all listed in the text box, while the graph shows the probability of capture for Great Balls in green and Ultra Balls in blue, both plotted against the variable H, which remember represents the fraction of health remaining. If we start with no status conditions, and let's suppose we're trying to catch a Butterfree, my favorite non-legendary Pokemon, which has a catch rate, a C value of 45, then we can see by looking at the graphs that the Great Ball is always better than the Ultra Ball, and this is regardless of the HP of our Pokemon. And if we now add a status condition, let's suppose we put our Butterfree to sleep, then we see that the Ultra Ball is now better at large health values. So if your Pokemon has a full health bar or a large amount of its health remaining, then the Ultra Ball is better. But once again, as we go to lower HP, the Great Ball again takes over the Ultra Ball and actually gives you a better chance of success. But where the Ultra Ball really comes into its own is when trying to catch rare Pokemon, aka legendaries. So let's again look at my favorite, Zapdos, which has a catch rate C is equal to 3. If we start with no status conditions, so S is equal to 0, then the graphs pretty much look identical. There's a very slight advantage to the Ultra Ball on high HP, and as the HP gets lower, the Great Ball eventually does actually become better once again. However, if we put Zapdos to sleep, so we increase S to 25, then we can see the Ultra Ball is much, much better for high health, and this actually continues all the way down to around 3% or so of the health of Zapdos remaining. If we have a Zapdos with 1 HP, so let's say we've used the move False Swipe, then surprisingly, the Great Ball is once again better at trying to catch a Zapdos which is asleep with 1 HP remaining. If only I'd known that as a kid. Remember to check out the link in the video description so that you can access the MapleLearn worksheet for yourself for free and have a play and see which other surprising results you can find. Thank you everyone for watching. Please do remember to subscribe to the channel if you've enjoyed the video, and I'll see you all again very soon. Take care.